Welcome to the real world. This lesson marks the introduction to the real numbers, which is where our algebra typically lives. Now, there's a symbol for the real numbers that you will encounter often in math, and it's we don't use it too much in Algebra 1, but you do see it later on, and it's probably worth showing you now. So it looks like the letter R, but it's got a double back on the R. So where a regular R would just have like the one bar on the back, the symbol for the real numbers has two of them and it looks like an R, and that is the symbol for the real numbers. So if you see that in writing, you see that in your math class, maybe in a math textbook, that's what it's referring to. It's a shorthand for saying the real numbers, and this lesson will help clarify to you exactly what those real numbers are. So up until now in your math journey, you have worked with positive numbers and zero. And so I want to create a picture of that. So we have a dot representing the number zero, and then your numbers go off in what we would call a positive direction. And so you have 1, 2, 3, 4, and so forth on forever. But you would also have, say, numbers that are in between. So you could have like 2.5, or you might have 1/2. So your fractions and your decimals. You could also have numbers that are irrational. So if you wanted to, you could find, say, the number pi on the number line, 3.141. You guys get the idea. And so you've worked with these numbers, but generally when you're first introduced to numbers, the smallest a number can be is zero. How can you have less than nothing? Well, the real numbers do extend the number line in the other direction, introducing the idea that numbers can be less than zero. And we don't typically start students off like this. So when you first show up to kindergarten, first grade, the concept of zero in and of itself can be kind of difficult to get around, that you have a symbol that represents the absence of something, let alone negative numbers. And so, but by the time you get to Algebra 1, we are usually in a position where, okay, we can understand the idea that there might be numbers less than zero. And so I'll go ahead and extend that off to the left. So you have on the right your positive numbers, and then you have on your left your negative numbers. Now, how do you read them out loud? Okay, because I will have students sometimes say some pretty weird things. Now, there's actually a fourth way that we can interpret this symbol, but we'll leave that for now. So right here, we've got this here, okay? And the most common way that you'll hear that read is just -4, okay? And so if you just see that by itself, usually people will just say -4. Now, another really common way to say that, though, is -4. Okay, and so somebody will look at that and say -4. Now, you might say, well, wait a minute, isn't minusing something that we do, like we do 6 minus 4, and that's an operation? Yes, and so that's maybe not the predominant way that we say it, but we will also use the word minus to indicate the presence of a negative number, which is maybe useful when we get to what is like subtraction, okay? Because we'll use that. Now, the third way, I'm going to leave that blank as like mystery for the moment, because we need to cover a little bit more in the way of vocabulary before we can attack that like last way of saying it, which can also be really, really useful. So here's our key vocab, opposites. Now, opposites, I want you to think about what you know about opposites already. Opposites come in pairs. So the opposite of light might be dark. The opposite of tall might be short. And so you never have just one word that's like its own opposite. When you think about opposites, you always think about pairs, and it works in both ways. So the opposite of tall is short, but the opposite of short is tall. And so you can phrase it either way. That's going to be the same concept that holds with our numbers as well. So opposites are pairs of numbers that are the same distance away from zero on the number line. So let's take a look at some example of opposites. So 4 and -4 are opposites. Okay, and so we could even write that out. 4 and -4 are opposites. But you could also phrase it the other way around, where you would put like the negative first. So -2 and 2 are opposites. Again, they come in pairs. And this would also hold for decimals and fractions. So we'll do 0.5. So 0.5 and -0.5 are opposites. Now, I am going to emphasize something in this lesson about picturing them or sketching them in your mind. So picture them in your mind or sketch them out. And I'm really going to advocate for you to actually sketch them out. There's a lot of research that shows that people that are good at math have what are called good visual models. So they're not just making stuff up in their heads. They are picturing really concrete things in their heads. So when you're thinking of opposites, I really want you to picture the idea of the two numbers on either side of the 0, and they are the same distance away. Okay, and so if you were to bust out your ruler, this would be 2 units away, and this would also be 2 units away, just in the other direction. But if you were, like, say, walking and you've got your fitness watch and you're counting your steps, it's going to be 2 steps away no matter which direction you go in. It's still like 2 steps away. So it's really, really good to have that mental picture of what opposites are. And you want to avoid saying the word opposite when you might mean something else. So while in our regular everyday life, we use the word opposite to mean a whole lot of things, in math, opposite means something very specific. It means pairs of numbers that are the same distance away from 0 on the number line. So what is that third way of reading this? The third way of reading it is the opposite of 4. And I had a teacher when I was in high school who would advocate for saying things that way in certain situations. He would always say the opposite of, and it would help us avoid errors with the negatives, because errors with negatives, they're called sign errors, are actually one of the most common kinds of mistakes that are made in all of math at all levels. So how would you read that out loud? -4, -4, or there might be times when you might say the opposite of 4. Now, graphing or plotting numbers on the number line. I am going to start this like big time. Don't underestimate how useful this skill is. So while you might feel like, oh, she is going throwback to elementary school on us, and I am in algebra, please, please, please do not underestimate this skill. It helps us to compare numbers, and it helps us recognize patterns in how numbers are related. When I was in graduate school, taking some graduate level math classes, we would put stuff on the number line all the time, because we would be looking for certain patterns to see if we could figure out how numbers were related or how sets of numbers were related to other sets of numbers. So getting good at plotting numbers on the number line is not something that we're going to make fun of. We are going to take the time to plot numbers on the number line. So we've got a set of numbers here. So we have -1.5, 3, threw in a nice fraction there, 7/2, and -2. So we are going to graph them and then order them from least to greatest. So let's go ahead and put 0 somewhere there. There we go. We'll go down to -4 and up to 5-ish. I guess that seems to be what amount of space that I have. So -1.5. So you want to really picture like where we're going here. So -1, and then we're going to go 0.5 more. So we're going to be located in between the -1 and the -2. Now, the other way you might do that is to leverage opposites. If you can think of where is 1.5, that would be between the 1 and the 2, then the -1.5 would have to be the same distance away on the other side. So this would be my -1.5. 3, probably get that with no trouble. 7/2, you might need to do a little work on this. 7/2 is 3.5, or halfway between the 3 and the 4. So there's my 7/2. And then we have -2 down here on the number line. And then ordering them from least to greatest, we would simply write them from left to right. Be mindful of directions, because every once in a while somebody might sneak in, order them from greatest to least. Okay, and here is my ordered list of numbers. Key idea, numbers to the left are less than numbers on the right, and numbers to the right are greater than numbers to the left. So basically, as you move from left to right across the number line, the numbers are getting bigger. And that is pretty intuitive when it's your positive numbers, but it's not quite as intuitive when we're talking about our negative numbers. So here's some examples of this. So if I've got my 0 and I have 1, 2, 3, 4, 5, so I come down here to the -5, and then I come up here to the 2, and you might be asked, like, which one is greater or less? Well, -5 is to the left, so -5 is less than 2. Or you might be asked, like, which one is greater? So you could say 2 is greater than -5. Now, I do have a video on my channel that goes into some pretty significant detail on inequality, so be sure to check that out. I'll see if I can link it in the description box if you'd like to go check that out if you feel like inequalities is a shaky spot for you. Now, here's where the number line can come in really handy. When both of the numbers are negative, then it's really, really easy for a lot of students in their heads to flip them around. And so you just kind of home in on the 1.5 and the 2 here, and you know which of those two numbers is greater. But when you're on the other side of the number line, it's like all of your distances are now in the, like everything's in the other direction. And so things can sometimes be backwards from your first instinct. So it's really, really helpful to actually graph it, look at it. So -1.5, again, is going to be like -1, and then -1.5 will be right in between the -1 and the -2, and then the -2 will be further over to the left. And so there's my -1.5, there's my -2. So -2 is less than -1.5, or you could say -1.5 is greater than 2. And again, seeing it on the number line can be a huge deal. So when you get to the practice set, and please check out the practice set to get some additional reinforcement with this, if you find that you're getting them backwards and you're trying to shortcut around doing the number lines, please, please, please don't. Okay. All right. So where do we see negative numbers? Where have you maybe seen them already in your life? Where are you likely to see them? Well, a common application would be with temperature. Okay, depending on where you live, but I think even if you live in a place with a warm climate, you have heard of like things like temperatures below 0, and you know, ooh, that is really cold. Now, depending on what temperature scale you're using, if you are in Fahrenheit, something below 0 is really cold, because freezing is 32. Because Fahrenheit. If you're working in Celsius, 0 would be the freezing temperature of water. And so anything where you might get snow or ice would be below 0. And so you'll have negative temperatures. Another common place where you'll see negative numbers is with money. And in that case, negative numbers would represent debt. Okay. So which is owing someone money. So you think, well, how can I have less money than no money? Well, if you owe somebody else money, because then even if you were to get some money, it still wouldn't be yours. You'd have to go pay off the other person before you could have any. So negative numbers would represent debt. And then any situation involving direction. Okay, so this gets into some science stuff. So situations involving direction, and I'll give you an example of what that might mean. So here's like the ground, and maybe you're building something up, and this would be positive, but maybe you're going to dig something beneath the earth, and so negative would represent going beneath the earth. So it's like you almost have a number line put onto like earth, where 0 represents ground level, and then building up would be going in the positive direction, and digging down deep into the earth would be considered going in the negative direction. And you will see tons and tons of stuff like that inside of your science classes. So you'll see lots and lots of applications of this idea of negative numbers. Last little piece here, key idea. This is something called absolute value, and you may or may not have seen that before, but the definition is really important. It is the distance of a number from 0 on the number line. I'm going to star that. I have seen a lot of students arrive in my math class with incorrect assumptions of what absolute value is. The symbol for absolute value are these two vertical lines. And they also serve as a grouping symbol. So if you've seen my video on order of operations, you know that P, that like in PEMDAS, stands for all kinds of grouping symbols. And we have just introduced a new grouping symbol. So how do we read it? So we might read something like this as the absolute value of 3. And we'll also say stuff like take the absolute value of 3, meaning that it's an operator. It's something that we actually do to the 3. So it's like a plus sign or a minus sign. You do something with the absolute value. So for example, the absolute value of 5 and the absolute value of -5. And I'm going to hop down here and say, let's take a look at that picture. So 1, 2, 3, 4, 5. So if you were to go and look at the 5, you'd ask yourself, well, how far away from 0 am I? And so you start walking like, okay, I am 1 unit, 2 units, 3 units, 4 units. I am 5 units away. When we are counting, we are indeed counting these spaces, not the tick marks. Okay, so the spaces, I have gone a distance of 1 unit, I have gone a distance of 2 units, and so forth. The -5 is in the other direction. But if you were to walk that distance, you would find that you are actually walking the same distance. And I use like your fitness watch that's counting your steps. Your fitness watch, if you're starting at the 0 and you're walking in one direction, the other direction, it does not notice what kind of direction you're walking in. So it would like log the same number of steps. So you might say, I took 1 step, 2 steps, 3 steps, 4 steps, and 5 steps. Absolute value is always non-negative. And I've had a lot of students come to my class and they'll say, oh, absolute value is always positive. Well, no, not always positive, because there's one situation where the absolute value is not positive. But it is true that absolute value is always non-negative because it does not take into consideration which direction you are going on the number line. So I hope this video was helpful. Please check out the practice set linked above and in the description box. Like and subscribe and comment to let me know if there are specific videos you'd like to see. I'll see you next time.